Paper of the day is a 7-dimensional analysis of hashing methods and its implications on query processing. In this paper, authors thoroughly study hashing for integer keys and carefully analyze the most common hashing methods in a 5-dimensional requirement space. First, data distribution, load factor, dataset size, read-write ratio, and unsuccessful or successful ratio. Each point in that design space may potentially suggest a different hashing scheme and additionally also a different hash function. They suggest that a right or wrong decision in picking the right hashing scheme and hash function combination may lead to significant difference in performance. To substantiate this claim, they carefully analyze two additional dimensions. 5 representative hashing schemes, which includes an improved variant of Robin Hood hashing, and 4 important classes of hash functions widely used today. That is, they consider 20 different combinations in total. Finally, they also provide a glimpse about the effect of table memory layout and the use of simply instructions. Their study clearly indicates that picking the right combination may have considerable impact on insert and lookup performance as well as memory footprint. A major conclusion of their work is that hashing should be considered a white box before blindly using it in applications such as query processing. All experiments are single-threaded in this paper and all implementations are of their own. All hash tables have map semantics that they cover both key and value. All experiments are in main memory. Every indexed key is 64 bits. They consider 3 different kinds of data distributions: dense, sparse, and grid. Let's look at the contributions of the paper. There are quite a few. First, data distribution. 3 different data distributions: dense, sparse, and grid-like distribution. In grid-like distribution, you can think of IP addresses. Second, load factor. 6 different load factors between 25 to 90%. Third, dataset size. They consider a variety of sizes for the hash tables to observe performance when they are rather small and when they are of medium and large sizes. Fourth, read-write ratio. They consider whether the hash tables are to be used under a static workload like OLAP-like or a dynamic workload like OLTP-like. For both, they simulate an indexing workload, which in turn captures the essence of other important operations such as joins and aggregates. Fifth, successful or unsuccessful lookup ratio. They study the performance of the hash tables when the amount of lookup varies from all successful to all unsuccessful. Sixth, hashing scheme. They consider linear probing, quadratic probing, Robin Hood hashing as described, but carefully engineered cuckoo hashing and 2 different variants of chained hashing. 7. Hash functions. They integrate each hashing scheme with 4 different hash functions: multiply, shift, multiply, add, shift, tabulation hashing, and member hashing, which is widely used in practice. This gives 24 different combinations. Let's start PS score. Overall, this paper is a bumpy read with experimental data explosions. It gets 6 out of 10 on readability. With 12 pages long, it scores 8 out of 10 on length. It's a measurement paper and the description of their approach is rough and feels incoherent, so it makes it 6 out of 10. Industry value on learning meter is questionable, so it gets 6 out of 10 on each. Overall PS score is 6 out of 10.